Inverse matrices. We can use inverse matrices to solve a system of equations, but I think it's more complex than substitution or elimination or Cramer's rule. And so we're not going to use it to solve, but we are still going to teach you how to find the inverse of a 2 by 2 matrix. Okay? And it is super friendly, super friendly. And this formula up here makes it look scary, right? Makes it look really scary. But all it is, we've got 1 over. There's my 1 over. And it says AD minus BC. Does that look familiar at all? It's just the determinant, right? So 1 over AD minus a negative 24. Now you guys help me figure out the pattern. If this is A, B, C, D, this is all shaken up, but how? What's flipped? The A and the D trade places, right? Those trade places, and then what happens to the other two? The signs change. So this looks all scary, but remember we're going to flip those 2 places and change the signs. So that means I would have a 7 here and a negative 2 down there, and then change the signs in the other corners. And then that would be 1 over 10 times this. And look at this like distributing. It's all we have to do. 1/10 times every element in there. So 7/10. Negative 4/10 would reduce to what? Negative 2/5. 6/10 would be 3/5, and that would be negative 1/5. Now, what I don't know, because of COVID and the time we missed, did you guys ever learn to multiply matrices last year, or was that something that was skipped? That was skipped? Okay. Okay. Good for me to know. We'll come back and hit it if we can. What would happen if I multiplied my original B times this inverse matrix? I'll put this back. If we are to multiply 1/10 by 10, what do you get? 1. If we multiply 3/7 times 7/3, what do we get? 1. When we multiply, oh, you're supposed to tell me it's not in the window. When we multiply inverses, what do we get? 1. So if I were to multiply these 2 matrices together, and let's call this guy B to the negative 1. That means the inverse of B. I'll make that more obvious right there. There's the inverse of B. If I was to multiply B times its inverse, I would get, that's what the matrix 1 looks like. That's the identity matrix. So multiply inverses together, you get 1. All we're worried about today is being able to find the inverse though, right? Let's look at problem number 2. What do we do first? One over what? AD minus BC, which is just the determinant. Negative 16 minus 2. You shake up that matrix without me, and then we'll compare. How'd you do? How did I do is a better question. Did I make any mistakes? All right. Well, that's negative 1/18. 2, -1, -2, 8. So that would, my inverse of C equals, distribute that through, and 4/9 negative. And we actually already answered this question. What's the pattern to help me remember how to find that inverse? It's 1 over the determinant. And then you guys are really good at this pattern. Switch these places. And those are minuses. Some of you are still working on that, so let me zoom that out.